Good morning, everyone, and thank you for joining us for this morning's sales presentation brought to you by Continental. This is Nikki from HCA Truck Pride, and I want to remind all attendees that you are on mute this morning. So please use the chat button or the Q&A feature inside Zoom to ask any questions throughout the broadcast. We do have about 30 minutes scheduled this morning, and we will ask all questions at the end of the presentation. Also want to remind you that this session, along with all of the webinars that we've done, have been recorded. This one's being recorded as well, and will be posted within 24 hours to our HCA Truck Pride University site. So you can always go back on demand and pull any of the webinars that we've done. Every morning at 11 o'clock Eastern time, we are running a 30-minute sales presentation, and at 3 o'clock Eastern time each day, we are doing a technical presentation. So today we are joined by Continental, obviously, for our sales broadcast. This afternoon we will have a technical presentation from Centric on their DuraFit line. That'll be this afternoon for our technical webinar. That really carries us through week 5. So there are 4 full weeks of webinars already posted to the university, and we will wrap up week 6 and 7 to carry us through the end of May. We are working on a June schedule. It won't be every day like we've run for the last 5 weeks, but it will certainly be a pretty hefty training schedule to carry us through June as well. So stay tuned for those announcements coming up. This morning we are joined by Zach Christensen, who is the product manager of hydraulic hose, and he's going to take us through this morning's presentation. Zach?
Thanks, Nikki. And thanks to all of you for dialing in this morning. As Nikki said, I'm the product manager for our hydraulic hose portfolio at Continental. Before that, I did 6 years of design engineering in our Norfolk, Nebraska hose facility, so for a total of about 8 years with Continental. Today, we're going to be talking about the importance of selecting the right hose and fitting for each application. And I'm going to begin by giving a real quick overview of Continental and who we are and what the experience we bring to the table for this type of topic is. So Continental was founded in 1871 in Hanover in Germany. A little bit of a fun fact about the company: the very first product that they made was actually a rubber horseshoe to kind of keep the noise down from the horses in the urban environment. And since then, they've been heavily involved in rubber technology, almost 150 years of experience, from tires and belts to the hose products that we're going to talk about today. What we bring is the technical competence from the raw material design all the way up through hose manufacturing and assembly, and then the global presence and customer care. So we have experience and expertise at every one of these steps that kind of helps to guide us. And what we're going to be talking about today is, first, we're going to look at some common methods of hose failure and how to identify those if you should see one of them come into your shop looking for a replacement. And then we're going to go into the methodology that we call stamped. That's going to help guide you through the process of selecting a replacement hose to make sure that we're coming up with something that's going to perform in the application that it needs to make sure we're getting the right product into the customer's hands. So without further ado, let's take a look at some of these common causes of hose failure. The number one most common cause of a failure for hydraulic hose is abrasion of the outer cover. And you can see in the photo what that's going to look like. What this does is it exposes the reinforcement layer, which is typically a wire braid or wire spiral, and allows the ambient atmosphere to corrode that, leading to loss of tensile strength in the wire. And this will end with a hose failure via a burst or a rupture if it's not removed from service very soon. So there's a couple different things you can look at to replace this type of hose with, but one of the solutions that Continental promotes is hoses with our X-Life cover. These are going to have 14 times the abrasion resistance of a standard hose, so you're able to last that much longer in the application. Next failure we're going to see is a failure behind the fitting. This can be caused by a couple different methods, either by exceeding the rated bend radius when the hose is installed on the equipment by bending it in too tight or too sharp of a bend. That creates a lot of stress on the hose fitting interface right there that you can kind of see, or by repeated flexing in the application at the end. So when you see something like this, there's a couple different solutions that may depend on the application, but these can include rerouting the hose so that it is not exceeding a tight bend radius or being flexed. Or in some cases, you can install a bend guard or a bend restrictor that's going to be either a plastic or in some cases metal, either a extruded sleeve or a spring guard that can take some of the tension off of that hose where it's being flexed around the fitting. Another common one that you can see is fluid incompatibility. So you see here how the fluid that was conveyed in this hose, this is a cross section, the hose has been cut in half, has absorbed into the tube and caused swelling and deformation of the tube material. This is what happens when the material that's conveyed is incompatible with the base polymer of the hose. So what you're going to want to do here is check the fluid compatibility for what's been used in the application. And an example of where information like that can be found, in the Continental Hydraulics catalog, there's a table of common fluids starting on page 476 that you're able to use to guide, and it'll give you a rating scale for each of the hose base polymer to tell you if it has excellent or good resistance and you can use it, or if it's not recommended. Another common cause can be exposure to external or internal high temperature. So exposure to this high temperature can accelerate the aging of the rubber, and it leads to brittleness, which then will crack if it is at all flexed in the application. And you can see examples of what that cracking might look like in the photo. So you have a couple options here. One solution is that we do offer a line of high temp hoses that are rated to 300 degrees Fahrenheit. This is our desert family of hose. Those are going to be able to resist the high temperature, both of the internal oil from the hydraulic circuit, as well as the ambient temperature. You also may have some options, depending on the application, to reroute a hose assembly if the area that is being exposed to external temperature is very localized. It may simply be routed next to a high temperature source on a piece of machinery, and it could simply be rerouted to avoid that temperature source if the internal temperature of the circuit is not actually exceeding the rated temperature of the hose. Next, we're going to look at a couple things to deal with the assembly process and the fitting. One of the more common failure modes we see is a improperly crimped assembly. So this can mean the finished crimp diameter is not according to specification. Either too tight or too loose can both cause failures in the field. If the crimp is too tight, meaning it is crushing the hose more than intended, it can lead to things like broken wires or cuts in the tube, which could lead to hose failure. And conversely, if the crimp diameter is too loose, can also lead to hose failure by not getting the designed retention force for the assembly, and it can lead to a fitting blowout like you see here. So you're always going to want to consult the manufacturer crimp recommendations while you're preparing an assembly. Continental makes this very easy to do by publishing our crimp specs online and in our mobile crimp app, which is called Continental My Crimp. We have a version for both our hydraulic hose portfolio as well as our industrial hose portfolio. And they can be found in the Android or Apple App Store free of charge. Another common issue with the assembly process is fitting short insertion. if the hose is not fully inserted onto the stem prior to beginning the crimping process, some of these serrations that are found inside the ferrule that are designed to hold the hose and fitting together may not be coming into full contact with the hose. As you see in this photo, there's really only one barb that's got full contact to the hose. So the retention force to hold the hose and fitting together is not going to be up to design, and you can see a fitting blowout or failure. The solution to this is to always measure the insertion depth or use an insertion block or jig. Pictured here is the version that Continental sells that matches with our B2 fittings. These holes are machined to the correct depth, so you simply insert the hose and mark it with a marker to get the correct insertion depth every time. So really having a good shop layout and these type of tools is one way that you can set yourself up for success when you're creating these hose assemblies. And Continental actually has come out with a new solution in the last month that we're launching to really make this process as easy as possible. And you'll see that we've included a couple of the solutions to these common assembly issues right in this shop in a box. So we include the insertion blocks for the common B2 and SG fitting series, and you can see those on the bench top right there, along with the paint markers to mark on the hose. And then we also include a tablet that's loaded with our My Crimp program so that you always have the latest crimp specs right at your fingertips. And this all fits into a nice solution package so that everything is going to flow really smoothly in the assembly cell, whether it's set up in one of your shops or at one of your end users that is crimping on site. This is our total turnkey solution. It rolls off the truck looking just like you see it in the photo here. So there's very, very little setup and assembly required. You pretty much are able to just plug it in and get to crimping. So this is an exciting new solution that we're launching. And if you're interested in hearing more about that, you can get in touch with your local CTM. All right, now we're going to get into the stamped process. So the 7 steps to selecting the proper hose. So if someone has come in with one of these failures, you're going to want to select the right hose to replace it with that's going to perform in that application. Stamped is a simple methodology that's really going to guide you through that process to make sure that all of the necessary questions get asked and answered to come up with the right hose for that application. So stamped is an acronym, and we're just going to walk through each of the letters, what they stand for, what they mean in order. So starting with S, very simple. S is for size. So this refers to the inside diameter of the hose. And there are several ways to determine this. Some of them are pretty obvious, some of them a little bit less so. And it's going to depend on what the condition of the returned assembly is in, which methods you have to use to determine this. A lot of times it's going to be relatively intact and you will be able to read it right off the lay line. Shown here is just an example of what a Continental lay line might look like. And you can see that the size is referenced in several different ways. There's the SAE dash size, -08, which refers to the size in 1/16 of an inch. So 8/16 is a ½ inch hose, which is also printed here, where you see the ½ inch fraction, as well as the DN size, which is the size in millimeters, nominal ID. You can also use various measurement tools to actually physically measure the ID of the hose if it happens to be very poor condition outer cover that you aren't really able to read and you're not sure what size it is. You can dissect the hose and measure it with, for example, a caliper. And why is this important? Well, when you're replacing a hose on a system, it needs to have the correct ID to handle the GPM of the hydraulic circuit as it was designed. And there's issues that can arise if it is too small, and there are different issues if it is too large. So if the hose you replace it with is undersized, that's going to increase the velocity of fluid, and it can cause things like damage to the inner tube and excessive heat buildup in the circuit, as well as excessive pressure drop. On the other side, if the ID is oversized and too large, the velocity is going to decrease, and you're going to see sluggish reaction time in the controls and increased cost of the hose itself. The next item is T. So T for temperature. This is going to refer to both the internal temperature of the circuit as well as the ambient temperature of the environment. So the hose must be able to handle both of these sets of temperature ranges, and you want to be on the lookout for anything out of the normal range that might require a special product. This can include low temperature solutions, for example, the Continental Arctic line that goes to -70 Fahrenheit. High temperature ranges, so the example from our portfolio here is the Continental Desert range that's rated for 2 Fahrenheit. And even higher than that, up to 450, you can use a Teflon line stainless steel braid hose like an SR14A. If it's exposure to ambient temperature only, there are some solutions as far as high temperature sleeving that can protect the hose. For example, if it needs to be routed next to a manifold or other heat source to protect it from that heat. And it can't be avoided by routing. So as I said, things that influence the temperature, there's the internal heat generated in the system. When oil is flowing through confined spaces at high pressure, it tends to build up temperature. There are cooling units typically on hydraulic circuits, but they may be underperforming or they may be not able to keep it below the rating temperature of some hoses. There are external ambient temperatures. For example, in the winter in the northern US and Canada, it can get well in excess of -40 Fahrenheit, which is the typical range for standard products. So you may need to go to a low temperature solution, especially if it's being used outdoors or even indoors. You see, like for example, forklifts that go into drive-in coolers at industrial food processing and that type of plant. So next is the A, which stands for application. So this refers to the environment that the hose must operate in and the performance requirements of the hose to handle that. So this is going to be things like the minimum bend radius, abrasion, and approvals from third-party agencies. For example, the US Coast Guard, ABS, which is the American Bureau of Shipping, or API for oil and gas type applications. So in order, minimum bend radius, this refers to how tight the hose can be bent in a installation. So you see here, this is the nice gradual curve that you're looking for. And then this radius is published for each hose and shouldn't be exceeded, as you can see in the dash line inside where it's been bent too tight for the hose, which is creating more stress at the fitting interface that can lead to failures. There are several solutions for this. You can use longer hose pieces to route differently to avoid these, or sometimes the application will call for a certain type of elbow to reduce these tight bends. For example, if you had a 45-degree elbow, then it would be a straight run. Performance requirements, as I said earlier, abrasion is the #1 killer of hydraulic hose in application. And you have some options here to fight against that. You can go to abrasion resistant covers like the Continental X-Life, or in extreme cases, the Continental Armor Coat, which has a ultra high molecular weight polyethylene film on the outside for the highest level of abrasion resistance. And then you can also get some different types of hose sleeving that can go on side of a standard hose to protect it from abrasion. There's woven Kevlar sleeving that you see here. And then there's also the spiral extruded plastic or PVC sleeving that can be found here. Continental has both of these in our line to protect hoses that are going into environments like this. And this can include approvals from third-party agencies. So as I said, certain specific applications will have third-party approvals that are needed to get their hose in that application. The most common one for HDA that you're going to probably deal with is going to be the DOT, I would expect. So we have some DOT approvals on some of our fleet hoses where for brake lines. All right, M is for media. This is the type of hydraulic fluid, so you need to ensure that it's going to be compatible with the hose inner tube. There are 4 common hose tube materials, so neoprene, nitrile, CPE, and then PTFE or Teflon. As I mentioned earlier, you can find compatibility data in the Continental catalog. So this is on page 462. And this is what it's going to look like, just a short snippet. The chemicals are going to be listed off, common chemicals in alphabetical order. So you find what you're looking for example, acetaldehyde, and then you find the base polymer of the hose in question, which is published on the hose spec page. So most of them are going to be nitrile, and you see that it is X, not rated for that. So you would have to use a Teflon product to handle this. P is for pressure, so this is going to be pretty easy, pretty simple. It's defined based on the maximum system working pressure, including accounting for any possible high pressure spikes. So to ensure safe operation and performance, you're going to want to have a relief valve in the hydraulic circuit that's going to handle some of these system spikes that may exceed, so you can keep it from exceeding the rated hose and fitting. Conversely, you would size that hose to be able to account for that system working pressure. One thing to note is that the fitting must also be related to the proper working pressure as well. If the fitting working pressure is lower than that of the hose, which is pretty uncommon, but it can happen, the hose assembly is rated only to the lower of the 2 working pressures. E for ends. What kind of connection type came in on the assembly? So if you have a failed assembly, you can use that to obtain the size. There's a couple different ways you can look at doing that. The simplest is someone like Continental. We include a lot of this information printed right on the fitting. You see here, it's got our part number printed right on it. Might not be visible after a long time in service though, so there's some other ways you can look at determining the ends. The family is determined based on the hose you've selected. So the Continental catalog or the Crimp app will both tell you what family of fitting needs to go to that hose. So for example, a B2 for braided hose or an SG for spiral hose. And then you need to determine the sealing type. So this is the metal to metal part of the connection just at the end of a hose fitting. There are a couple of common families of connection type. The first one is tapered threads. So this is going to be like an NPTF thread or male pipe. It's common, but not really recommended for hydraulic assemblies. It has tendency to leak and can't really handle vibration or retightening in application. The most common thread type in North America is the JIC 37-degree flare. There's also the SAE 45-degree flare that's common in automotive, in on-highway type applications. And then you can have a metal to rubber sealing method that involves an O-ring. This is going to give you the best performing seal for hydraulic systems, short of a flange connection, which is the next group. But this is better for higher working pressures. And the way you can tell between the different types of threaded connection is to utilize a tool like this on the screen. So this is a thread ID kit. It has a couple different tools in here that allow you to measure the angles of the sealing surfaces, the spacing and pitch of the threads or between the thread crests, as well as a simple caliper for basic dimensions. And given those 3 sets of tool, you are able to narrow it down to the specific threaded connection that you need. Here's an example of how some of these work. These are using the thread gauges to measure. Right here, this is the sealing surface that it's measuring. Right here, it's checking threads per inch or per millimeter, depending on if it's metric or standard. And then finally, the last letter is the D for delivery. So how does the customer want this? Is it going to be a bulk hose in a standard box or real quantity? Is it going to be a custom packaging? Is it an assembly? So this is going to be pretty much determined based on what your customer is asking for. So those are the 7 steps. Continental also offers a nice new tool that really guides you through this process. This is the digital version of Stamped that's at our website, hoseselect.com. So this is, anyone can get there. It's free to use. It's wide open. Anyone can look at it. And it just, you go through some simple questions here that are modeled off of the Stamped process, although it's not word for word stamped on the side, but you answer a few simple questions and it's going to kind of guide you to what some acceptable products might be. So it's also great to get simple spec sheets. If you know the hose that you have, for example, XR16SC, you can search for it in the search window and it'll take you to basically the catalog page that can also be printed out to form a spec sheet. So this is a really nice tool. So you don't necessarily have to remember every step in that Stamped acronym, just have it in your mind and know that there are tools out there that can help guide you to selecting the right hose for the right application. So with that, I will turn it back over to Nikki and see if there are any questions.
Thanks, Zach. I want to remind our attendees that you guys are on mute, so please use that chat button or the Q&A button at the bottom of the screen to ask any questions to Zach. Also want to remind you that this session was recorded, so within 24 hours, by this time on Monday, we will have this loaded to the university and you can pull the webinar up on demand. Last little commercial would be for our technical webinar this afternoon with Centric, and then we will kick off week 6 of 7 with a sales presentation from WAI on Monday. We did not have any questions come through, so Zach, I want to thank you so much. Randy, I know you're there on mute, but thank you guys for taking the time this morning. We really appreciate all the information, and thank you to our attendees for logging on. We will talk to everybody this afternoon, and hope everybody has a great day in between. Thanks, Zach.
Thank you, and have a nice day, everyone.